Hi, welcome back. This is Professor Ridge. Today's lesson is 6.3, Complex Rational Expressions. A complex rational expression is a rational expression that contains a rational expression within its numerator and or denominator. So basically, a complex fraction is a fraction within a fraction, complex rational expression. So an example would be like 3/4 over 1/3 plus 2/5. That would be a complex fraction because you have a fraction within the fraction. Okay, so those are all rational expressions. So you could have something like x plus 3 over x plus 2 over 1 plus 1 over x plus 3. So that would be a complex rational expression. All right, so there's two methods for simplifying rational expressions. Okay, the first method is multiplying by the LCD. Multiplying by 1. I like to call it the LCD method because you're going to multiply by LCD divided by the LCD of all the little fractions. So let me show you what I mean. Okay, so let's just do something simple like this. 1/2 plus 2/3 over 3/5 plus 5/6. And what you do is find the LCD of all the little fractions. Okay, so what I mean by little is like the fractions that are within the fraction. So the 1/2, 2/3, 3/5, 5/6. So I want the LCD for 2, 3, 5, and 6, which that will be equal to 30. So what you're going to do is you're going to take this fraction and multiply it by 30 over 30. And you're going to take this 30 and distribute it to both terms. Now, the beauty is of this technique is since we're multiplying by that LCD, we know for sure that it's going to cancel all the denominators for each of the little fractions. And we do the same on the bottom, distribute. So it's 3/5 times 30 over 1, 5/6 times 30 over 1. Normally I don't show the steps, so I'm going to go 1 times 30 divided by 2 times 1, which is 15. And then 2 times 30 divided by 3 times 1 is 20. 3 times 30 divided by 5 times 1. Really what I do is I'm going to go 5 goes into 30 6 times, and then 3 times 6 is 18. But if I had a calculator, I can go 3 times 30, hit equals, divided by 5, hit equals, and I would get 18. So again, without a calculator, I just go 6 into 30, it's 5, and then 5 times 5 is 25. And then you add the tops, 35 over 43. And that's it. So we can use that exact same technique with rational expressions. It's the same idea. You're going to multiply the LCD over the LCD on the top and the bottom. Okay, so again, I'm going to find the LCD for all the little fractions. So that's R, S, R, and S. So the LCD for R, S, R, and S is equal to RS. So I'm going to multiply the top and bottom by the LCD of all the little fractions divided by the LCD. So I'm going to get 6 over R. So normally I don't rewrite it. I'll put RS right here where LCD is and RS right there. times RS divided by RS. So again, I'm going to multiply the 6 times the RS divided by R. 1 over S times the RS. And then 2 times the RS over R, plus 3 times the RS over S. And to be truthful with you, I don't even ever write this step, just when I'm showing you in notes. So 6RS divided by R, the R's cancel, and I get 6S. Here, the minus, then the 1 times RS divided by S, so the S is canceled. You get R. Now the bottom, R is canceled, so I get 2S, plus, and then here the S is canceled, so I get 3R. And then I look to see if I can reduce this, which I can't, so I'm done. Okay, so again, forgot to mention this, complex rational expressions. Complex doesn't say that it's hard, it talks about the structure. It's a fraction within a fraction. So these problems could be easy, could be hard, could be any level of difficulty, but what makes it complex is the structure. It's a fraction within a fraction. Let's try a couple more. Actually, let me show you method 2. And this is, you're going to view the big fraction bar as a division symbol. So with this technique, you're going to view that as a division symbol. So you're going to take the top, divided by the bottom. Okay, so our first step is we need to make one fraction on top, so we get common denominators. So let's see, 1/2 times 3 over 3. So we get 6. Same thing on the bottom. Let's see, we want to get common denominators there. We want 30ths. So we go 3/5. So we do them as two separate problems. Do the top and the bottom. So we're going to get on top 3/6 plus 4/6, which is 7/6. And on bottom we got 18/30 plus 25/30, which is 43/30. Now we're going to view again that as the division symbol, so we're going to multiply by the reciprocal. Let's see, and then 6 goes in 35 times, so we get 35 over 43. And you see that's the same answer as we got before. So it's kind of pick your method, whichever way you want to do it that method or the other one. Doesn't matter. So let's do that same 13. 9 times out of 10 I'm going to pick the method 1, the LCD over LCD method. Sometimes I do this method, but it's pretty rare. Okay. So I'm going to do this again using method 2. So that's going to be equal to 6S RS. So when I get common denominators to the top, so it'll be R RS. Common denominators on the bottom. So I want RS. So that's going to get me 6S minus R over RS divided by 2S plus 3R over RS. Now we're going to view the fraction bar in the middle is divided by, so we're going to take the top, leave it alone, take the bottom, flip it over, and multiply. Of course, the r's cancel, the s's cancel, and we get 6s minus r over 2s plus 3r, just like we did with the other problem. So again, it's your choice. You can use method 1 for all of them, you can do method 2 for all of them. If you learn both, you can pick and choose. So my rule of thumb, the only time I'm going to use method 2 if the top's already one fraction and the bottom's one fraction. So like right here, see one fraction divided by one fraction, then I'm going to use fraction 2. Otherwise, method 2. Otherwise, I'm going to use method 1. Just find the LCD of all the fractions, the little fractions, and multiply the top and bottom by that LCD. Okay, so if I look at 24, again, just as a rule of thumb, if it's not one fraction divided by one fraction, I'm going to do the LCD method. So I'm going to multiply by the LCD for a minus h, a, and 1, which is just going to be a times a minus h. And remember, when you distribute this, that LCD is going to go to the top of each fraction. So it's going to be 1 times a minus h over a minus h minus 1 times a minus h over a over h times a minus h over 1. And I don't need to write that over 1. Alright, and so now when I simplify, I do the canceling first and then write what's left over. A minus, here the a's cancel, so I'm left with a minus h over a h, a minus h, just rearranging it in alphabetical order. Now here I got to distribute this minus sign and simplify. So let's see, we're going to get a, which is 0, and then minus a, or minus a minus h is just h. So the top is just h, bottom there's nothing to do. And now you can see I can cancel out that h. So I'm left with 1 over a minus h. So that's my final answer there. Alright, let's try another one. So on this one, my first step is I'm just going to go ahead and factor all the denominators. So factors of 6 that subtract the 5, so that's 6 and 1. Put in my signs, bigger one's positive. Signs are different. And then the next one, oh, it's the same thing. And the bottom, got x over factors of 4 that add to 5. So that'll be plus or minus 4 minus 1. And then that's the same thing. Now actually, you know, I said that normally I would do method 1, but in this one, since I noticed that these have common denominators, that'd be real easy for me to make it one fraction. So I'm going to use method 2 this time. then the bottom is going to be x minus 2 over x minus 4, x minus 1. That's only because they had common denominators. So that was really easy to do. Now I'm going to view that big fraction bar in the middle is divided by, so I take the bottom one, flip it over. Okay, the x plus 6 cancels, x minus 1 cancel, and I'm left with x minus 4 over x minus 2. Alright, okay, let me show you another one. So let's look at number 50. So again, I'm going to factor everything. So factors of 10 that add to 7. So that's 5 and 2. Both of them are plus. Now what I normally do with this minus is I move it up to the top so I don't forget about it. I want facts 12 to add to 7. So it's a minus 3, a minus 4. And then on the bottom, factors of 6 that subtract the 1. So that is 3 and 2. My signs, bigger one's negative. Signs are opposites. And again, I'm going to move the minus up to the top. Facts 20 that subtract to 1. It's 5 and 4. The bigger one's plus, minus. Okay, so now I'm going to find the LCD for all the little fractions, which is going to be a plus 5, a plus 2, a minus 3, a minus 4. So it's going to be all those. So it'll be those 4 things. So what's going to happen is when it's going to be a plus 5, a plus 2, a minus 3, a minus 4. It's going to be all of those, and it's going to go on the top of each one, and then 1, a plus 5 will cancel. The a plus 2 will cancel, so I'm left with a minus 3, a minus 3, and a minus 4. And then for the second one, I'm going to get minus 2. The a minus 3, a minus 4 cancels, so I got a plus 5, a plus 2 left. And now on the bottom, the a minus 3, a plus 2 cancel, and I'm left with the 2 that was there. Right, these are canceling, so what's going to be left is the a plus 5 and so that's a minus 3, a plus 2, so a minus 4. Then I got the minus 1, and the a plus 5 cancels, and the a minus 4, so I got a plus 2 and a minus 3. Okay, so now what you need to do is multiply everything out. So we're going to get a squared, doing that. So we're going to get a squared minus 4a minus 3a, that's minus 7a plus 12, minus 2 times a squared plus 7a plus 10, and then we've got to distribute that negative 2. A squared plus a minus 20 minus 1 times a squared minus a minus 6, which is going to give me so I distribute the negative 2. Distribute 2 on the bottom. distribute the negative 1. Now combine all your like terms. So I've got negative a squared minus 21a minus 8. In the bottom I have a squared plus 3a minus 34. And neither of these two factor, so it's not going to reduce, and that's going to be my final answer. So that one's, a little bit tedious. So that one's definitely complex in both ways, right? It was a lot of work, and it was a fraction within a fraction. Anyway, that's simplified. So there you go. That's 6.3. So that concludes today's lesson. Go to my math lab and complete your exercises there, and I'll see you next time.